Now let's start with the topic propagation of sound. How the sound will propagate. As we all know that sound is produced by vibrating object. कुनै पनि object if vibrate, that will create the disturbance, and that disturbance will travel through the air particles, and that reaches up to our air. We discussed in our previous class, that way we'll hear the sound. Now how the sound will propagate. Yesterday in yesterday's class also we discussed how sound कसरी travel गर्छ भनेर, that we discussed. Now in more detail we'll do. That means it's a sound. Actually sound is a wave. Clear? Wave is basically, what is wave means? It is basically a disturbance created in the medium when the particles sets neighboring particles in actions. In the last class we discussed actually sound चाहिँ के हो? Wave रहेछ. Wave भनेको चाहिँ के हो? कुनै पनि wave produced भयो भने in the air particle, that sound will transfer through that waves, and that is called the disturbance, and that reaches up to our ear. Up to our eardrum. Clear? अनि हामीले अस्ति पनि डिस्कस गरेको थियौ यो कुरा. त्यसरी नै it's a waves, and sound waves are characterized by the motion of particles in the medium and are called mechanical waves. That means this sound wave is called a mechanical waves. And another thing what we have to remember, in order to travel that wave, अब मैले अस्ति पनि भन्नु त details मा, now I'm telling you, म बोलेको it will reaches up to your ear, हैन, कानसम्म पुग्दैछ. किनभने I'm talking, म बोल्दैछु, that mechanical wave is producing, अनि त्यो प्रोड्युस भएको वेभ चाहिँ कहाँ गएर ठोक्किँदैछ, डिस्टर्बेन्स कहाँ क्रिएट गर्दैछ, इन द एयर पार्टिकल्स. क्लियर? इन द हराइजन्टल डिरेक्सन्स. क्लियर? अनि त्यो चाहिँ द्याट रिचेस अप टु यो एयर ड्रम, अनि ब्रेनले अर्डर दिँदैछ साउन्ड इज प्रोड्युस, यु हियर द साउन्ड भनेर. अगेन अनि त्यो पुग्नुको लागि चाहिँ द्याट इम्पोर्टेन्ट थिङ्स वी निड, द्याट इज द important properties of sound we have. त्यतिखेर चाहिँ वेव्सले चाहिँ के प्रोड्युस गर्छ, that is the important properties of sound that will get the compressions and the rarefactions. क्लियर? अब के चाहिँ प्रोड्युस हुँदैछ जब साउन्ड तिमी कुनै पनि भाइब्रेट अब्जेक्ट भाइब्रेट हुँदा, there will get compressions and the rarefaction. Compression will denote it with capital letter C and rarefactions with R, capital letter R. Now, when a vibrating object moves forward, just look at this tuning fork. अब यो जब भाइब्रेट हुन्छ, we know दुईपल्ट अगाडि आउँछ, दुईपल्ट पछाडि जान्छ. That is the forward and the backward. ओके नि त, थर्र थर्किँदा. तर त्यो काउन्टलेस हुन्छ, हामीले यतिपल्ट भन्नु सक्दैन. तर कुनै पनि भाइब्रेटिङ अब्जेक्ट यु अल हेभ सिन, जस्ट लुक एट हियर अल्सो, व्हेन अ भाइब्रेटिङ अब्जेक्ट मुभ्स फरवर्ड, भाइब्रेटिङ अब्जेक्ट चाहिँ जब मुभ फरवर्ड गर्छ, इट पुसेस एन्ड कम्प्रेस द एयर इन फ्रन्ट अफ इट, क्रिएटिङ अ रिजन अफ हाई प्रेसर्स. अब जस्ट लुक एट दिस फिगर. जब यो ट्युनिङ फोक के हुन्छ, भाइब्रेट गर्दाखेरि इट्स मुभ्स फरवर्ड, मुभ गर्दा चाहिँ इट गेट्स अ रिजन अफ हाई प्रेसर्स. द्याट मिन्स कम्प्याक्ट, हेर्दा यहाँनिर कम्प्याक्ट प्रेसर्स पाउँदैछ एयरको, एन्ड द्याट इज द कम्प्रेसन्स वी कल, एन्ड इट इज डिनोटेड विथ क्यापिटल लेटर सी. लुक एट द फिगर अल्सो. नाउ दुईपल्ट अगाडि गयो, दुईपल्ट पछाडि जान्छ. अब नाउ नेक्स्ट, वेन द भाइब्रेटिङ अब्जेक्ट मुभ्स ब्याकवर्ड मुभ जाँदा चाहिँ इट क्रिएट्स अ रिजन अफ लो प्रेसर्स. एयरलाई रिल्याक्स गर्दो रहेछ, अनि त्यहाँनिर लो प्रेसर्सको के रिजन क्रिएट गर्छ. मिन्स फरक एयर पार्टिकल्सहरू फरक विल गेट, द्याट इज द लो प्रेसर, इट विल क्रिएट्स द लो pressures called rarefaction and is denoted with capital letter R. As the object moves back and forth rapidly, a series of compressions and rarefaction is created in the air. That means जब अपन कुनै पनि object backward or forward जान्छ, that time it creates the compression region, high pressure को region र low pressure को region create गर्दो रहेछ. And that reaches, that means they are in the form of waves, and that will create a disturbance, and that reaches up to our air. Clear? That way it will propagate, the sound will propagate. And another thing what you have to remember, that means the important properties of sound. Number one, that is the compressions and the rarefaction. Compressions means the region of high pressures, and compression is the region of high pressure, and rarefaction is the region of low pressures. Clear? Now another thing what you have to remember, in order to propagate the sound travel गर्नुलाई we need the important thing, it's a mechanical wave we know, and waves like travel गर्नु it needs a medium. Like it's a medium like air, water, steel, etc. for its propagations. Another thing I'm like, sound needs a medium to travel. A sound like pani travel गर्नुलाई medium it needs. अब हामी basically बोल्दा हामीले maximum medium is the air. हामी air मा बोल्छौं नि. In the vacuum मा we can't create the sound. अब तिमी कुनै पनि बोतलमा मुख हालेर बोल्नु खोज्यो त साउन्ड निस्किँदैन. That is the vacuum place. जहाँ एयर को पनि absence छ भने sound will not travel. Clear? That means for the sound, in order to travel or propagate the sound, it needs a medium. किनभने sound is a mechanical wave हो. Wave लाई travel हुनु पर्यो, अनि त्यो that reaches up to our air. Clear? And next what you have to remember, that is the longitudinal wave and transverse wave. That is the two important thing you have to remember. And that is the waves. Waves कति types को हुँदछ? There is two types of waves. One is longitudinal wave, another one is transverse wave. Now first we'll do longitudinal wave. And sound waves are longitudinal waves. Sound waves से के रहेछ? Longitudinal waves. We'll discuss about this. Sound waves से के रहेछ? It's a longitudinal wave. Just I'll give you the example. Suppose you have one string. Clear? String like if you press stretch that string. Stretch गर्दा just look at here in this the screen. Screen मा हेर्दा जब हामीले त्यसलाई stretch गर्दा the pressures, the compression हामीले के पाउँछ? छुट्टेको पाउँछ. That is the example of rarefaction. जब त्यसलाई stretch गर्दैन छेउमा लान्छौ त्यतिखेर you will get the compressions, packed पाउँछ. तान्दाखेरि छुट्टेको पाउँछ, त्यसलाई छेउमा लाँदा packed पाउँछ. And this is the example of sound wave. भर्खर पढ्यो नि compression and the rarefaction, that is the example. Now a longitudinal wave चाहिँ के रहेछ? It's a directions of particles and directions of motions are same. Particles को र motions. अब मैले तान्दा motions भयो, त्यो motions को waves पनि के छ? Horizontal छ हेर त. Just look at here in the pictures, horizontal. अनि अर्को particles को पनि के छ? Horizontal only. त्यसले गर्दा चाहिँ हामीले sound wave लाई चाहिँ के भन्दैछ? Longitudinal wave. किनभने directions of particles and directions of motions are same. That is the longitudinal axis मै छ. Longitudinal. Clear? Now next we have what is, अर्को चाहिँ हामीले के पढ्नु पर्यो? The transverse wave. What is transverse wave? Actually transverse wave is a light wave. Example is light wave. Light याद छ. Sound wave को के रहेछ? Longitudinal. Transverse wave चाहिँ के रहेछ? Light wave. Now अब transverse wave चाहिँ के रहेछ? The particle's displacement is perpendicular to the directions of wave propagations. That means यसको motion same हुँदैन. Particles र motions को चाहिँ same directions मा हुँदैन. के हुँदो रहेछ? It is in perpendicular directions. Suppose directions of the motions horizon. Just look at here. directions of motion is in horizontal axis, horizontal जाँदैछ, whereas movement of particle is in, example I'll give you. Before this example I'll tell you, suppose you have tie one rope, okay, दोरी बाँध, अनि त्यो दोरीलाई एउटा हातबाट तिमीले यसरी हल्लाऊ. Just look at here, हल्लाउँदा you'll see the waves, ups and downs waves you'll get, isn't it? अब यहाँनिर चाहिँ हामीले यहाँबाट के भन्नु छ, डाइरेक्सन अफ मोसन, यो मुभ भएको मोसन चाहिँ हराइजन्टलमा छ, whereas the particles, यो दोरी चाहिँ कस्तोमा छ, vertical, हल्लिँदाखेरि माथि मुनि vertical ठाडो आउँदैछ, ओके न. त्यसले गर्दा द ट्रान्सभर्स वेव्स चाहिँ के रहेछ, the particles displacement is perpendicular to the directions of wave propagation, and the example of this transverse wave is light wave. Clear?